Great. Well, hey everyone. Thanks for being here today. Super excited about chatting today. So I'm Diego Oppenheimer. I'm a managing partner at Factory. We're a venture fund that's specialized in AI investments. I also happen to be help a couple of different LLM based startups with product, and so I've been pretty deep in the ecosystem. Um, One of the things that are really interesting is that this tremendous popularity, this kind of Cambrian explosion of use cases and interpretations of how we can actually use, build AI applications. I think really the kind of quote unquote chat GPT revolution has become fascinating in terms of the inspiration that it's given to developers, hackers, and the people who have been inspired to go build for truly what we can start thinking about as the software 2.0 or 3.0 if you want to call it, in terms of how it gets powered by AI. So in today's talk, I'm going to really kind of do a little bit of a survey of the environment and kind of the tools that are out there. I'm not going to be, I can't go in depth. There's so much going on, but I kind of want to talk high level about how people are building these applications and what kind of tooling they're using. So let's figure it out. Great. So let's start a little bit into, because I think a lot of people still have a little bit of this question in terms of foundational models versus large language models. And so the first thing I want to do is, these foundational models are trained on extremely large amounts of data. And they're, if we think about kind of foundational models as these broad general purpose models that are really aimed to capture, a lot of capabilities and knowledge. The kind of large part comes usually because there are a billion plus parameters. And they're really kind of designed and architected so that you can be adapted and fine-tuned so that to specific data. So examples like GPT-4 and Clip and DALL-E fall in this. So foundational models, really think of it as the kind of generic or superset. And inside that, there is obviously language and there's image and there's multi-model models. So large language models are really designed for specifically understanding of language. So, and you can see there are BERTs and there are llamas and GPTs in this category. They're really trained on massive data sets. And, you can see the tasks that exist in terms of classification, generalization, summarization, and more. So I'm going to go back between foundational models and large language models a little bit, but this can kind of give you that framing of, how to think about them. So let's go a little bit into, kind of a history. So in terms of how do we actually get here from a research perspective, right? So, back in the day, started with a bang bang, very sad, no models, emptiness, nothing. The first kind of iteration, or not first, but kind of big push in terms of, machine learning was in self-supervision. We started seeing models that had, 125 to 350 million parameters. Its capabilities were to be able to kind of replicate what it had seen and kind of spit it out. And the kind of data sets that were actually used to kind of generate these were really around, kind of small web, so small web components, or book dumps. The trend ended up going to bigger models, right? And this is when we started actually getting into the kind of large models, which are, getting to that, how do we get to that 100 billion parameters? These, the more, a lot of proof showed that the bigger the models, the more the capabilities that were coming out of it. So we started seeing these 1 to 100 billion parameters. Really taskless text generation was really kind of the first kind of things that came out of this. And, the data was really kind of trained on all the web. So now we're getting to these instruction tuned, and massive models that they can actually follow task and instructions. They are using actually heavily curated data sets. They're getting ginormous, right? The 10 to 200 billion parameters. They can generalize to tasks. They also can listen to feedback in the sense that you can actually work with these models in terms of instructing them to get to results and providing context. And we're going to talk about some of the tools that allow you to do that. And the more important part is, from a data perspective, these are heavily curated data sets and labeled data at web scale with human feedback. And the cost and the scale at which this is being done is quite impressive. And really kind of the the newest models have been, there's a lot of work going on into actually kind of being able to do that. So as the size and data quality increases, you get more generalized, more generalization and in context behaviors, but at a much, much higher cost. And so we'll talk a little bit about that, what that looks like as well. Cool. So, one of the interesting things about early stage development of platforms is when the first kind of platforms show up, people start with a very kind of like basic wrappers around that. And there's actually a parallel to this in general software and technology, right? So when the first microprocessors came out, there was essentially wrappers around single board computers. When the first operating systems came out, the first applications were really like wrappers around utilities. If you think about kind of like Unix utilities and kind of like, like Norton as one of the first kind of like applications was really just OS capabilities wrapped around, wrappers around that. In the internet, we got these like wrappers around like Unix and network utilities. And what we're seeing today in kind of like the generative AI world is really this like wrappers around, well, not just LLMs, but also around foundational models in general. So we're in this kind of like first phase, which is pretty natural, where these thin wrappers around these foundational models, and there's an explosion around it. And the core thing that's actually happened, right, is the capabilities got to that holy shit moment, right, where we're looking at, it really feels like magic. And so my personal experience, I've been working with these foundational models in a bunch of different contexts. I like the best translation I have to it is it feels like you're Neo in the Matrix, right? Like you're just accessing content, you're being able to do things at a speed and a productivity level. And so that holy shit moment of using ChatGPT for the first time, has really driven to, tons of Discord servers and hackers, and market maps are being made, and an unbelievable amount of people are building, what is today the basic kind of wrappers around these foundational models. But that is kind of like, if history provides true, this is kind of the start of a whole industry that will be building deeper and deeper applications as the models get better, as our tools get better, and as we understand how to build these applications in a better way. So the ecosystem is completely thriving. And, I cheated here a little bit, and, I stole this from the folks over at Firstmark, so I want to give them credit. But like the data landscape and the AI and ML landscape is just growing. And what's actually happened, especially in that kind of ML ops category, is we're seeing actually now LLM specific tools, right, that are just coming, that are going everything from the most basic convenience wrappers around OpenAI APIs to actually complex tools for orchestrating and multi-step reasoning to very simple databases for prompt templates. And so what we are going to see here is that as developers continue to experiment with LLMs, a thriving ecosystem is going to be cropping up to support that work. And these tools are designed to enable developers to iterate quickly, build amazing features on top of these LLMs around that. And so we're going to dive here a little bit into kind of like a couple categories of those tools that are emerging, so you kind of understand like what we're seeing. So first of all, I think let's start with, what does it take to build a LLM based application? And to give a little bit of that workflow, so we just generally understand, is today fairly easy. Grab an API around an LLM, plug in your experimentation prompt tooling, potentially if you need it, and I'll explain when you don't need it, vector database and data integration, and you got that V1 product. And to be clear, like most of the stuff that we're seeing today, all right, and most of this explosion is really around these 4 first boxes, which is we're getting to that first version of the product. And we're still in that kind of like holy shit moment around that first version of the product. So as we continue experimenting with these LLMs, then this, kind of like the thriving ecosystem kind of keeps going up, we're going to see these steps go through. The first is experimentation and prompting. We go into knowledge retrieval and fine tuning. In experimentation phase, developers are really tinkering with the prompts. These LLMs have a really interesting API, which is natural language, and it has some specific ways of working with it, with that API that require certain tooling, or at least not require, but like we want an abstraction on some tooling to make it a little bit easier. And this might involve actually chaining prompts, through that. And the next is knowledge retrieval, which involves providing like kind of like relevant context to the model so it can actually improve its accuracy. So these generalized models, if we can actually reduce and provide context into them, allow you to, improve that accuracy, and also it behaves better and run cheaper. From that perspective. And so finally, fine tuning is really where, when we're going to go in like into the second version, where we can actually get really, really what I call kind of like snipe data sets. So highly curated, specific data sets to show examples to these models so that you can actually fine tune on them to improve your model accuracy and actually reduce your inference latency, which really what matters when you're actually thinking about production use cases. So let's jump in a little bit into what these, kind of places are. So as I mentioned, like we're kind of, version 1 is really where all the action is today. And obviously there's a ton of people working on much, much deeper stuff. So I don't want to like take that away, but like, if you go look at, and I was looking at this, kind of last night, one of my favorite newsletters, no relationship to them, but like Ben's Bytes, like, aggregator of a bunch of links and new tooling, right? So, hundreds and hundreds of applications like a week are popping up, essentially building in this kind of like V1 world, which are really wrappers around these LLMs. So, for effect purposes, that moment where that blows our mind, like getting to the next step is actually doesn't blow our mind as much, even though there's a lot of complexity getting into that V2 that version 2 of applications. So let's start jumping into, some of the actual like tooling here. So the first one is really what I would call kind of this like, experimentation and prompting. So to get actual desired output, from an LLM, developers often need to experiment with different prompts and chains of prompts. And this can actually be quite complex and time consuming. So fortunately, what we have right now is kind of emerging tool sets like LangChain and Llama Index, that have helped to jumpstart and manage this experimentation process, connecting to, because these APIs are natural language, that mastering requires that, experimentation between single and chain prompts. And so these tools have really come out to like help us connect to data sources, right? Provide context and grab a bunch of data, provide indices to actually be able to run through that, through that data, coordinate chains of calls, and provide other core abstractions like agents that allow you to build kind of the applications of the future. And so this is really, again, like the core of this tool set is around being able to very quickly and iterate through that experimentation and orchestration process, and abstract away some of those, things. And, some of these tools have gotten extremely popular. And if you just track by kind of like their GitHub stars, which, it doesn't really mean how much they're being implemented, just really shows interest. It's really fascinating to see how they've inspired, I think it's fair to say that they've inspired a whole revolution of hackers to go build applications off of these large language models. So then let's talk about knowledge retrieval and, kind of vector databases. So these, one of my favorite descriptions around, large language model is like, it's the smartest goldfish you've ever met, right? So, what that means is like, they don't really have memory, right, at this point. And to be able to actually have like, a memory or understand what you're doing over time, you have to kind of provide it context and kind of like guide it through what you want. And so the best way of actually guiding the context, right, is to actually pass it in relevant content so it can actually frame it in a way that it, it understands around it. And so one of the ways of really, finding relevant context and actually doing it in a very cheap and efficient way, especially because the way embeddings work, is actually using vector databases. And so there's been the vector databases are very popular right now. There's tons of funding going around them. But the real reason around this is that they're actually really, really efficient for vector similarity searches, which is your retrieval. They're really effective at storing billions of embeddings, which is what you want to do to provide, if you convert documents in different contexts into those embeddings to be able to feed them into these LLMs. And they're really efficient, have really efficient indexing capabilities. So when you start thinking about, retrieving similar documents, really vector databases are this core component of giving memory and then helping to improve output quality. So if you're actually building an application and what you're trying to do is that to have, as I said, smartest goldfish, you want to provide memory to the application and understanding over time. These kind of vector databases tend to be a core component, and so learning how to use them and actually implement them becomes particularly important. So then let's go into kind of like what these version 2. So we talked about the kind of like product, the building and like the kind of thin wrapper layer around the traditional model. But that's actually not what you can do today. There's actually a lot of things that you can do in terms of making these models more accurate, and also faster and cheaper to run. And that usually kind of steps down to this fine-tuning step. And to be able to do fine tuning, you really need super high quality data. And so I think it's really interesting. And there's you'll probably see a couple of talks on this, but my good friend Alex I'm sure will be we'll doubly clicking on this. But like this is really kind of playing out in terms of the data centric AI movement that started a couple of years ago, where the core quality of the data and the kind of like manicuring of data sets is proven now to be the actual one of the most efficient ways of reducing latency and increasing accuracy through this fine-tuning process for these LLM-based applications. And so while they generalize really well, the effect of actually trying to get them like really, really like customized or at least working in a better way is about getting data sets that are very, very curated and specific to task. And then providing fine-tuning, APIs to be able to do that. And so in this process, you can do, there's a couple of different patterns around that. So the fine-tuning one is the one that allows you really to improve performance and when accuracy is critical. And then another case is what you do is distilling these models to smaller versions of the model that run in a cheaper way, but that don't lose that accuracy. But you just don't need a lot of the other properties that these large models potentially have. So you can think about this distillation process where I can get a smaller, still large language model, that has the same accuracy for those tasks, but is no longer actually, it's much cheaper to run and much faster to run. So as these use cases come up, where latency matters, where accuracy matters, where cost and efficiency and the unit economics of running these models, is an important factor, you have to start thinking about these techniques, to be able to kind of boil those down. So finally, we get into kind of like monitoring, observability, and testing. And so the first thing is like, let's be clear, like we're still working with deterministic workflows, right? So, probabilistic workflows. So while most, and it's a really interesting because as we look at the general population of software developers and people who are interacting with these models, for a lot, it's the first time that they are encountering probabilistic workflows. So people who work in data science and in machine learning, like they're very comfortable. They understand, that there's confidence scores and like how these models produce results. But for the general population, like, we're used to like when I do the exact same thing, over and over again, like I should get the exact same results. And that's just not necessarily true in a probabilistic world. And on top of that, when we're actually trying to assess performance for large language models, we really have to assess quality via the user interactions, right? We have to understand what the user's doing, what they're actually like complementing around that. And so how do we measure performance is a really interesting question inside the, large language model good. And how do we understand how the good generated content is? We talk about this problem with, hallucinations and overconfidence in the results. But, as we start thinking about monitoring, observability, and testing, we're going to really have to think about, okay, why, how do we observe the user interactions and what they do after it and what their results? So being able to provide that feedback in to assess performance. We're going to really have to double down on building A/B testing around the full workflows for product analytics, because the actual result in the chain, it's not just about one model and testing the model, but it's actually the entire workflow and A/B testing that entire workflow to understand, if they're working or not. As these models larger models get larger, and more. There's a giant swell around open source models. So we're seeing a lot of these generalized models coming out. How do we compare on them? How do we understand just the eye test of being able to like run the same prompt against a couple of different models isn't really going to do the trick. So open source efforts like Hallam over at Stanford are really providing comparison frameworks on a task by task basis. So there might be room here for actually thinking about, look, what is frameworks for kind of like full workflows and testing those against each other. And some of these tools are starting to pop up in things like Honeyhive, where they're really giving you like the ability to kind of test and iterate through those workflows. And finally, what's the performance impact? We need to be able to look at the performance directly impacts the UX. So if we think about, how fast or slow these large language models, the very, very large ones might take a second and a half to produce a response. If we're doing hundreds and thousands of these inferences every day, not only is the cost really big, but the actual cost to the UX and the experience that the user has is really affected. So how do we actually measure the full user experience of the application and understand, hey, when should we be using a cheaper, faster, lower latency model because we're affecting the user experience in that way? So getting to, finally, like one of probably the most interesting pieces of working with these LLMs is, they can really generate plausible but incorrect information, which actually really poses a threat to what I call low affordability use cases, like medical diagnostics and financial decisions. So if we think about what high affordability versus low affordability looks like. So high affordability to be wrong, right? That's the framing that I use to kind of think about some of these use cases. So if you think about your GitHub Copilot, if you think about your suggestions in your email, if you think about generating an image, like these are all high affordability use cases for being wrong. Like, you might, it's not going to really affect anybody. Like, sure, you can ignore the suggestion. This is why we see so many, like this explosion of copilots type, workflows, because they're just enhancing. There's a human there verifying it. Like, it's really about getting you to faster. But once we start going into low affordability use cases, things like medical diagnosis, financial decisions, things that where this technology should be applied to, because it has the opportunity of truly revolutionizing, those industries. That's how we actually can start thinking about, okay, what do we need to do that? So we need to start guardrailing these models. So how do we ensure safety, accuracy, and reliability? Teams at Microsoft, the people, companies like Microsoft have full dedicated product teams actually doing this. And it's really interesting because it's really kind of going to be at the core of how we explore the future of these, how we explore the future of using these LLMs. So tools that start emerging that, define rules, schemas, and heuristics for LLM outputs are going to be crucial to build trust in those systems so that we can actually start building and trusting these kind of what I call low affordability to be wrong scenarios. So finally, to kind of wrap up here, I'm going to leave with a couple of predictions around this. And so the first one is that, like, there's a ton of developer tools, and usually iteration cycles are what defines the winning developer experiences. So if we think about what we originally started when we started working with deep learning, there was a launch of libraries and kind of frameworks like Caffe and TensorFlow, and as we iterated through it, new ones emerged like PyTorch that adopted very, very quick popularity. So it's really interesting to see, and I think it's too early right now to think about, okay, which one of these frameworks that are become extremely popular today. The good thing around this is I think like we're going to see the iteration cycles really quickly, and these new libraries are actually enabling that iteration cycle. Second one is, and again, this is probably not too crazy to think, which is like, if we start about what traditional ML, and something I spent a bunch of time in, and kind of like what I call previous generation of ML ops, every single step of building an ML application was hard, right? So I had to build a data warehouse and capture the data. I had to hire and train an ML expert, label that data. I had to go build a model, and I had to build an inference point, and then I had a version 1 of the product. That level of difficulty, the way I compare it to is like originally, before AWS and before cloud, like, just to build a web application, you have to go stand up servers, there's a lot of manual stuff to go do. This is kind of out of the box. Now I can start, right? It's extremely easy to use a LLM API. It's literally interacting with it in English or any language, right? Prompt design is actually fairly straightforward. And you can get to complexity, but it's actually really easy. And then, obviously there's complexity around dealing with the orchestration and the data integration, but, we can go very, very quickly to these version 1 products. So I think we're going to continue to see even deeper explosion of these really interesting version 1 products as these large models become bigger and have more capabilities. And they're going to really continue to inspire this revolution around this future of software. And I'm wrapping up here, Demetrius. It's the last one, I promise.
It's all good, man. Keep it going. It's awesome.
Yeah, the final prediction, and I stole this from Alex, so I'll give him credit. I think we're going to see this, GPTU, and what this means is like this distillation of open source models that are going to be highly contextualized to your organization. So the ability to grab these models that are based, trained and fine tuned on your data, on your organization's data, that are specific to your business, I think are really going to explode. And what we're going to see is MLOps tooling that is going to help achieve that, right? And at the core principle here is that data is the most durable moat. The last mile is always where the value is generated in these workflows. And so at the core, what we're going to be seeing here is, okay, what is the next version of these that are really going to help you tune and specialize these large language models specifically to your organization's data, to your personal data, and do that. So that's kind of like the concept of that GPTU. So this has been super fun. Hopefully it was useful. Happy to chat with anybody later, but thanks, Demetrius.
Dude, killer. And since I ended up burning a lot of time at the beginning, we were supposed to do a whole Q&A session for you right now. But if anyone wants to talk with Diego and keep the conversation going, ask him any questions, feel free to jump into the Slack link that I added into the chat. And that's the MLOps community Slack. You can @ Diego Oppenheimer and ask him questions. We set up a conference channel that you can hit up. And that's that. I have one question, though, for you, Diego, and it's not about LLM ops, if we're going to call it that. It is more about, you've been in the game for a while. I mean, you've been doing this. I'm not going to say you're an old hat, but you've been doing it for a while, right? What's different about this time around? Do you feel like there's actually some legs here, or are we going to find ourselves in another winter soon?
So I think no, I'm so bullish about what's going on right now. Like I think like we are. I was actually thinking about this last night, and I was like, I can't imagine a more exciting time to be involved in kind of ML than right now. Like it feels like for some people it's almost like dizzying, like just keeping up. But like the level of innovation that is happening at this speed, I don't think we've ever seen it in the history of software. Yeah. And it is so exciting, and an entire generation of developers and hackers and kind of like software artists are being inspired to go build, and they're just going to build, and people are just building, and like the speed at which they're building is just awesome. Like I legitimately, I could not be more excited. I think this is we will look back in history as this being a crucial time in our existence as humanity.
Oh, dude. Killer. I'm excited. I'm very excited. And you just talking to you, listening to you makes me even more excited. Some people were commenting on your visuals, and I think it's worth noting that I think you made all of these visuals with every kind of
I tried to be almost fully powered for the entire talk. So I generated the outline, I created the speaker notes, I generated the visuals, and I typed all using 4 or 5 different foundational models from different sources.
Dude,